Hey everyone, this is Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem, and we are going to explain the piece of code I have put here. And the second goal is to see how we should behave in a real interview. So let's get started. So remember, in a real interview, the first step is always try to understand the question. If the question is kind of obscure, please bring up some questions to the interviewer to clarify, and also think about some edge cases at the very beginning. So let's see. It's maximum average subtree. So given the root of the binary tree, find the maximum average value of any subtree of that tree. So if a subtree of a tree is any node of that tree plus all its dependents, the average value of the tree is the sum of its value divided by the number of the nodes. So let's see for this one. This tree, like for this node, the maximum average subtree is 6 because it only has one node. For this one, it is 1. For this one, it is 6 plus 5 plus 1. So the average of this tree is, what is that? It is 4, okay? And the maximum average subtree would be this one, which contains only one node and is 6. So let's see the constraints. So the number of the nodes in the tree is between 1 to 5000, which means this tree is not going to be empty. And each node has a value between 0 to 100k. And the answer will be accepted as correct if they are within this range. Yeah, so you know that the computation of double can have some range, like for the very minimal numbers after the dot. So let's see how to solve this problem. And also I will explain the piece of code which is about the solution. So the general solution is using DFS. So for DFS, we define a function. So the DFS is going to return a class called node property. So what is node property is defined here. So the node property contains three things. The first one is the average of all the nodes within the subtree, and the number of the nodes within the subtree, and the max average of all of its subtrees, of all the subtrees under this root node. So let's see this the definition of the DFS. So for recursive function, usually you start with defining the exit. So if the left is none, right is none, which means it is a leaf node, then we just return this one. So the average is just the root dot value, and there is only one node, and the max average, of course, it is the root dot value itself, because it says that the value is between 0 to 100k. So for sure, this one is going to be larger or equal to 0, so we don't need to worry about like -1, whatever. So for this, and after we define the exit, we need to define, we will define the return value we are going to return. So initially, we define everything to be 0. And if the left subtree is not none, then we are going to call DFS recursively on the left subtree. So for the left subtree, it is going to return the number of the nodes within the left subtree, and the average for the left subtree, and the max average of all the subtrees under the left node. And similarly, we are going to, if the right node is not a non-pointer, then we are going to call DFS on the right node recursively. And the return value, we need to update node property average with, so this is about the current sum of all the nodes from the left subtree. This is the sum of all the nodes from the right subtree, and this is how many nodes within the left and right subtree. And we use this formula to calculate the average, and this is a count. We just need to plus the number of the nodes from the right subtree to the count, and we will update the max average as the maximum within the current max average of the node property, or if the within the right subtree there is a larger max average subtree, then we are going to replace the max average for node property. So after all, after we call recursively the left subtree and right subtree, we need to consider the left subtree and right subtree plus the current root node, which is this property, which is this formula. So we calculate all the sum, including the root node, for all the nodes under this root. And then there is this is the number of the nodes within the tree under this root. And we also update node.property because we include the root node itself. And we update the max average with, if the current max average is the maximum, then we just don't need to do it. Otherwise, we will need to. Otherwise, if we include the root, the max average get larger, then we will need to replace the max average we currently have. And finally, we return the root node property. So that's essentially how we solve this problem. And the runtime is going to be O of n. N is the number of the nodes within the subtree, within the tree actually. So for coding part, take care about the correctness, the readability, and also take care about about your speed. So don't be too slow because there is limitation on the interview time. So that should be pretty much it about the interview. And also don't forget to do some testing after you finish doing coding. If it is a runnable platform, feel free to use it to help you debug. If it is not, then you will need to go through some test cases manually and explain how this piece of code is going to work on the sample example. So that's it for this coding question. And also I have summarized all the questions in the sheet by category of different companies, the data structure, algorithm, and we also have the corresponding link for the YouTube video. You could take a look. Yeah, that's it. Thanks for your time watching this video. I hope you enjoy it. If you like it, please help subscribe this channel. I'll see you next time. Bye.